It's good to see everyone here. So we will be recording the meeting. If you're uncomfortable with your webcam being in the recording, then just turn it off. Otherwise, yeah, we'll get going. So this week, today we're focusing on graphing and on presenting data. So yesterday we learned a lot about like wrangling and aggregating and summarizing data. And today we will be doing more of the visualization. So if everyone has filled in the like check-in form, that'd be awesome. Otherwise, at the end, we'll send out a feedback form. If you could fill that in, that'd be excellent too. And so we'll introduce or reintroduce ourselves again, I guess. So I'm Josh, and I'm the secretary, and Bridget will run the workshop with me. She's our education's officer director. So yeah, Bridget will be running the first part of the session, so I'll hand it over to her.
Thanks, Josh. Josh, if you could just drop in the chat the link for today's Markdown file so that everyone could start to download that. So today we're going to use a different file from the one we used yesterday. So Josh, I think you need to send it to everyone. So Josh is going to, he's dropped that in the chat below. So if everyone could go to that link, same process as yesterday to download it. Josh, maybe if you just show, in case there's some people here that weren't here yesterday, just the process to download that and open it up on R. If you could share your screen, please.
All right, I'll share now. All right, so just go here and you'll see this, and what you want to do is download the second lesson. Download it, and then it'll be in your downloads here, and you want to open that, and it'll open it up in R, and it will look like this. So you just click on the file if you have R installed. If you don't have R installed, you can use RStudio Cloud.
Josh, we can't see your screen. We can only see the
So when you open it up in Google Chrome, you just be able to double click it and it'll open here if you have R installed. Otherwise, if you haven't got that installed, you can set it up on RStudio Cloud. But I think most people will have R installed or have some working version of R now. If you don't, just let us know in the chat and someone will help you through with that. And yeah. Yeah, Bridget.
Thanks so much for that, Josh. So has everyone been able to download that file? If you've had trouble, just quickly send some messages in the chat. So we have a couple of members from the committee here today. So Shelley and Jeremy and Jess and Yushu are here. So if you have any trouble, they'll be able to help you in the chat. So just send through any questions. Any questions at all, don't feel there's no such thing as a stupid question, just send them through and then the team will be able to help you out so that you can follow along and hopefully have as good a time as you did yesterday if you came, or if you're just here for the first time today, well then welcome, and we hope that you have a really good time today. So today we're building on sort of yesterday's lesson. So when you sort of bring in data that's not tidy, we can tidy it up, wrangle it, so using tidyverse like we learned yesterday, and then sort of the goal after we've wrangled is we want to do something with it. So today we're going to do something with it. We're going to graph. So we're going to learn how to graph these difficulties. Oh, sorry guys. We're going to learn how to graph the data that we've wrangled. So there are some smaller wrangling steps that we will go over today as well that weren't covered yesterday, but generally it will be about just graphing. So same as yesterday, we need to reload our packages. So yesterday we installed tidyverse, but as we said yesterday, even if you've installed it before, you have to reload it every time you restart up your new session. And could somebody just send through the link again, please? Thank you. But we have a new package today, LibreDate. So we wouldn't have used LibreDate yesterday. So obviously on our machine that we've used it before, but I think for everybody else, could you uncomment this line to install it for the first time? So remembering in R, if we have a hash key, that's commenting out the code, so the machine doesn't read it. So if you've never installed LibreDate before, make sure that you uncomment it so that you can download it so that we can follow along with today's lesson. So awesome. So we've learned some wrangling concepts. We'll be learning some more, and it's very important for data science or any sort of data visualization to be comfortable with these. And then also we're going to learn not just how to graph and visualize, but also some of the core concepts behind it. And we're going to sort of dive into why we'd be using these and how they'll be helpful. So we're going to use the same data set from yesterday's session. So it's the housing data set. So make sure that you load that first. It should come up in your environment on the right. After that, we're going to first look at dates. So in R, there are many different data formats. So you might have seen in the PDF that we sent out, there's some basic types of data, which are like characters or numbers or Boolean values. But we also have the date format type. So if we open up our data frame, we can see that we have a column here called date, and it has all these dates written here in this format. So they're day, month, and year format. So what we can do is when we load in a new data set, we're not sure if it's properly already converted to date type, we can use this function here, class. So this will tell us what class this column's format is. So we can see below that it's character. Well, we don't want it to be character because if we try to graph it in character format, the RStudio won't realize that it's a date. So when you try to graph dates or things like that, it won't show up properly because it thinks it's a character. So in order to change it from character to date, we can use that package that we were talking about before up there called LibreDate. So yeah, so we're going to use this function here called asDate. So the asDate function turns character or number. So sometimes it won't be read as character format, sometimes it'll be read as number, but it changes any non-date format into date as long as it's got sort of numbers within it. So we call that function, and here we put what column from the data frame we want it to read through. So we want the house data frame, and we want the date column. And then we have to tell the computer as well what format our data is in. So as we saw before, our data is in a date, day, month, year form, but some data you might get, it might be year, month, date, year. It just depends in what format it's coming. And just a reminder for everyone that this session is recorded, so we'll be sending that out for people to use if they've missed something or they need to go back through it. But maybe could we just send back through the link for today's workshop file just for any people who are coming in maybe a little bit later. So if we run it here, we can see that we've converted using the asDate function, and then we've used the class function again, but this time it's converted to date type. That's what we want, and that's what we need when we're ready to graph. So you can see up here, originally it wasn't, it was a character, and now it's a date. So once you know that you're ready to go and that your date format is ready for graphing. Okay, so one of the most important functions that can be sort of used in R when you're wanting to look at sort of statistical insights into a data set, especially if you're thinking about, you've got a new data set, you don't really have any idea what might be interesting within it, but you don't want to just start graphing blindly, we can use our summary function. So one thing to be careful of is that I know that yesterday we learnt about the summarize function that we used with group by, but these are two different functions. So at the moment we're using the summary function. So just in case you've got a little bit confused, the summary function gives us the statistical summary. So we run it for the whole data frame, house data frame. And once we run it, it comes up with every single column within the data frame, a summary. So for a data frame like this, there are lots of columns. So there are lots of summaries, but we can look at ones that we're particularly interested in. So obviously for columns that are just character vectors, there's no real summary because there's no maths to be sort of calculated on them. But ones that are really interesting to look at could be, for example, where's the house price one? Yeah. So here we can see our minimum price in our data set for this column is 85,000 and our max is up to 9 million, I think it is. Yeah. So we've got our minimum, maximum, then we've got our first quarter, our median value, our mean values, and our third quarter. So it's got those summary statistics all printed out neatly for you for each individual column. And another thing to note, you can see here, it also has NAs. So an NA means that the data value is missing. So if we have this car column, it means for 62 rows in our data frame, in the car column, there's no entry or there's an invalid entry that hasn't been able to be read properly for that particular column. So that can be another useful thing for summary statistic to look through to see how much missing data you have. Because when we're doing data visualization or any sort of work with data, taking note of missing values is one of the most important parts. So you can see here, there's a couple, this one has 6,450 rows missing. So there's a lot of missing values in this data set. So we can also do some quick error shooting sometimes with this. So a particular one that we might want to draw our attention to is the year built column. So as we can see here, the minimum value is the year 1196, which immediately would come to your attention that this is probably an error value. It's highly, I would say, impossible that a house was built in Victoria in this year. So it's easy for us to find sometimes errors as well in the statistics. So very useful function for everyone to sort of be aware of. So today we're going to learn about different type of graphing. In particular, there is the base R graphing and Ggplot are ones that we're going to focus on. So when we talk about base R, as we learned yesterday and today, R itself as a language comes with many sort of different functionalities, but there are packages that people have created and can be used, which can sort of give us extra capabilities or functionalities that other people have created. So this is just the basic graphing functionality that was inbuilt in R, sort of independent of any packages. So as we go through, you might see it's a bit more basic than Ggplot, which will be our second example, although it is useful for us to learn because in some situations, in particular some of your units, maybe if you're a student at Monash, they will only let you use base R, and potentially there may be some other situations in industry or in your work, maybe if you have a I'm not sure, low processing computer might be useful. And also it will help us understand sort of the basics of how graphing was built up in R. So as we can see here, I'll run this for us quickly. So there's 3 examples that have popped up. So we've got first a histogram. So a histogram shows the distribution of the data. So you can see where the most numerous values are. So this is the scientific notation. So we've got 0, 2 million, 4 million, 6, 8 million. So here we can see our main data is sort of clustered around the, let's say, 500,000 to 1 million mark. So we can see that most of the houses in the data set are around this price range point. And you can also see here the frequency. So we have around just over 6,000, I would say, houses that are around $500,000. So that's a quick histogram of the house data set price column. We've also got a scatter plot. So this is scattering the house price, the property price against the amount of rooms it has. So you can see here that, for example, this property here has around 5 rooms. I think it's 5 rooms, and it's $8 million. So here we can start to interpret some patterns in the data. Also, we have a box plot graph. So box plot showing the property prices against the amount of bedrooms in the property. So I'm not sure, are many of you familiar with a box plot? Maybe if you could just send through in the chat. Are we quite familiar with box plots or not really? Yeah, so some people aren't quite sure. So with a box plot, maybe I could just use this one with the 5 bedrooms as an example. So it sort of shows, if you remember our summary up there, we have our minimum, maximum values and our median. So you can see that the most numerous 50% of the data is included in this box, with the most common value here on this black line. And this is our bottom percentile and our top percentile. And then these are our outliers. So these are points that are very far apart from the majority of the data. So you could generally say, is the cursor supposed to be moving? Yes. Is it not moving? This little pointer, no one can see it. Oh, it's awkward. Oh, can you see it now? Moving? Okay, sorry about that. I'm not sure why that wasn't moving. So this box here, this gray box, is our 50% top majority of data. So the most of the data values for 5-bedroom houses are sitting around this price point, which is between, let's say, $2 to $1 million. And then we have some really extreme prices, so not the norm at all, around even up to almost $8 million to around $4 million. So they are individual points. So each of these circles are called outliers, and they represent one individual property. Whereas here, these are groups. So we've got top 50, the most numerous 50%, and then we've got our other 25%, so the 25% lower values and the 25% higher values. So if you can see here, the boxes for the 10 and 20 bedroom houses are very flat, which kind of indicates that maybe there's only 1 or 2 entries or very small entries, or in some rare cases, they're all exactly the same entry and they may be very numerous. But we would probably assume from this data set that maybe there's only 1 or 2 sort of values contained. So that's our box plot. If you have any more questions about the explanation I gave, drop them in the chat and hopefully our team can help you out with that. But going back up to starting with our histogram, if we want to make a histogram in base R, we call the hist function and we put our data that we want to use and then we call whichever column we'd like. So here we've got price, but we could change it to bedroom 2 if we'd like. And then now you can see that it's changed to bedrooms. So we can see here, can anyone drop me in the chat maybe what, if they saw this graph, what is it telling you about sort of the general amount of bedrooms in the property in this data set? Anyone's interpretations when they read this graph, what it tells them? If you could drop it in the chat maybe. If they were to look at this histogram, what would it tell them? Anyone? Number of bedrooms on the x-axis, yes. Awesome. So most houses, pretty much all houses in the data set have between 0 to 5 bedrooms. We have most of our bedrooms in the 3 mark. So how many properties have more than 3 bedrooms would we say? Maybe around, who can tell me how many bedrooms would have about, how many properties have around 3 bedrooms if we're looking at this? Be like 6,000, let's say. Yeah, so we'd say probably 6,000. So as you can see, you can change it to any column you'd like quite easily. For the first column, it is 0 bedrooms. 0, 1, 2, 3, 4, 5. Yeah. So that's because these are discrete values, but generally histograms are used for continuous values, so they may indicate sort of a range. But for this one, they're discrete, so it can be a little bit harder to read off the markers. So awesome. So that's how we make a histogram with our base R, just a plain one, no sort of customization. For our scatter plots, which is this second plot here, we use this width function. So first we have to use width, and width tells us that we're going to use this data. So with this house data, we are going to plot price versus rooms. So our first value is our X. That's a good question about the frequency density. So this is just the frequency at the moment, but we will show frequency density in our a little bit lower in one of our other examples. So you can't see the exact normal distribution, but we will talk about that soon. So this is just the frequency for now. So here we've got our X value, X-axis value first, and then our Y value second. So we've got our rooms, and then we've got our prices. So just think of it as with this data plot X, Y. So for the box plot, we've got this little thing. I'm not actually sure what it's called. I call it the squiggly line, but if somebody knows its real name, maybe you can drop it in the chat. A tilde. Okay, good. Sorry, I've never said it out loud, but thank you. So we've got our box plot function, and then we use the price, and then the tilde, and then bedroom. So the price is our Y value, and so it's actually the opposite. And then this is our X, and then we're using the house data here. So I think one important thing, if you sort of following through this, and it maybe seems a bit overwhelming to remember, is that one of the main things about programming is getting the general gist of what sort of functions are available. If you can't memorize the syntax off the top of your head, that's fine. It's very common to just Google it whenever you need to use it again. So don't feel too stressed about that. But just remembering what we can do and having a general idea will be helpful if you want to visualize later on. So that's how just very basic, just calling it. But if we want to customize it and, you know, make it a little bit more intuitive to a viewer or even more attractive, you can see here that we have our scatter plot again, but this time there's a couple of changes. So we have a title for our graph, and then we have changes to the axis names, so they've been labeled properly, and we've also changed the color of the dots or the markers. So with that, we've got a similar syntax as before with the house data plot price room, but you can see that we've also got XLab. So XLab is how you can customize whatever you want the X label to be here. And we can do the same with Y for YLab. Then we can also set the title of our graph, and we use main. So these are very important. I would encourage you, if you're ever creating a graph to show someone else, to always include these in a descriptive way, especially a title. And also for your assignments, make sure you always label them because they will deduct marks for that. Here we've got PCH. So PCH is talking about the marker style. So this is the 16, but I could change it to 5. And you can see that it's changed to these diamonds that have no filling, they're just the lines. And then you can change the color. So you could change it to whatever you'd like. You could change it to pink. There's a couple of colors like pink or navy that are inbuilt. If you want to put customized colors, you can use their hex or RBG codes, which you can look up online and then just enter them directly. So if you have any questions about things that have been said, just make sure that you drop them, and our lovely committee members will be able to help you. So as you'll see on the link that, the file that we've dropped to you guys, there's also a link here that shows you all the different marker shapes. I think there's about 26 of them. So you can change them up however you'd like. But now we want to make something even maybe a bit more advanced. So I don't know if you all noticed from yesterday's class, but we have a type column in our data set. You can see, where is it? Oh, here. So you can see type. So it's, if we want to section our data using this column, there's a couple of things we need to do. So first we need to find out how many different types of values are in that. So when we run this unique function, so unique will return all the different values that are possibly contained within this column. I think Josh ran us through it yesterday, but for this type column, we have H, U, and T. So H stands for house, unit, and townhouse. So if we wanted to have our same graph as last time, but maybe we want to separate the values. So we want a different color and shape for unit, and a different one for house, and a different one for townhouse. We can separate them so that we can look at our scatter plot and not only see the price difference between the amount of rooms in a property, but also to separate that by type of property. So looking at this, is there any sort of inferences that anyone can make even more now that we've sort of separated the different property types? Any sort of interesting things people have noticed from this graph that they want to drop in the chat for everyone to see? No? That's okay. Yeah, the price ranges for houses. Yeah, so the price range for houses is a lot bigger. Yes, that's a good question. So I think you can set the transparency. I think it's the alpha parameter. But one thing that sometimes can't be really helped is that if there's a very dense amount of data points, is sometimes they will always sort of overlap each other. So that was a good point I was going to bring up next, is when creating this graph for our lesson plan, we play around with a lot of different color and marker types. So as you can see, house is the much more dominant sort of entry in this data set. So we tried to make it a sort of more lighter and less overbearing marker types so that you could actually see all of these. It's a good question. So the answer is for base R, the way we do that is first we set our canvas. So we set it similar to the one above with house data, plot, price, rooms, and then we set out its title. And then we have to set the type to N. because if we don't set it to N, then all of the price and room data plots will just be on our axis like above. So the first thing we do is we set it to N, so it just becomes like a blank canvas. Then we have to subset each of our types that we want to plot. So you can see here width, and then we use this subset function. So we're subsetting house data by type H. So then we're going to tell R that we only want to use the type H, and we are going to use the points for price and room, and we want to set the color to yellow. And we can do that for each individual type, and that will tell R that we want to subset, and it'll always put them together for this sort of type because we're using that same data set with the type N. So that's how we put them all together onto the same graph. So there's sort of like mini subsetted graphs within the same graph. So you can see here that we've got our points. So we've set different color for each one, and I decided to set a different marker type for unit. But you can set them however you'd like. You can play around with it when you're making your own visualizations. And then also we've set a legend at the top so that people can interpret the graph. So you can see that first we choose for the legend function a place where we want it. So we want our legend in the top right. You can have it in top left, bottom right, bottom left, center. You can change it to wherever you'd like. But one important thing to do when you are listing is you are manually putting them in. So R doesn't know which one is which. So you have to put them in the same order. So if I put the color, oh no, sorry, these are the marker type 1, 18, 1, because here we've got marker type 1, marker type 18, marker type 1, color yellow, color navy, color green, legend text is house, unit, townhouse. So just make sure that when you're adding them in that you match up in your vector the right text and marker type and color. So hopefully that was clear for everyone. If not, please drop down in the chat so that we can help you out. Otherwise, I will keep moving on so that we can get through everything planned for today. So lastly, we just wanted to go over this graphing. PCH is the marker shape. I'm not sure exactly what PCH itself actually stands for, but it refers to the shape. So here is a diamond shape is PCH 18, and this circle, which is got no color in it, is PCH 1. So it's just the number that refers to the shape of the marker. So now we've got our graphing for mathematics. So this is, yes, so plot character, that makes sense, that would stand for that. So here we've got our probability density histogram. I can't remember who asked about that, but so this is it here. So we've got our price histogram again, and then we've got the normal distribution curve over the Gaussian curve over it that we've overlaid over it. And as you can see here now, they are negative, so it's like 0.000007. So we've got our probabilities of these sort of density values on this side. Could somebody just send through that link again, please, for the Markdown Form? So in order to make this, we have to actually first create this histogram graph, and then we're going to overlay this curve over it. So first we need to find our mean for whatever value we are creating our histogram out of. So this can be obviously done with any sort of data you have, or even some sort of sample or simulation data. So this might be useful for some of your maths units if you're doing any. So we've got our mean. So we've set our mean for our data that we're using for our histogram, and we've also got our standard deviation. So we've found the square root of the variance. And then first we're going to make our histogram, so similar to before, except this time we're going to set it to probability equals true. So beforehand, the the default is probability false. So above, our histogram was probability false. So if it's false, it will give us the frequency. If we set it to true, it will give us the density. So if we want to overlay our curve over it, we need to set it to true. Otherwise, as you can imagine, your curve will be very flat. So that's what you need to set it as, true, if you want to have a density histogram. Breaks is setting how many bins you want your histogram to have. So here we've set it to 40. Obviously, the higher this number, the more bars in the histogram there'll be, how more bins it will have. So it's sort of can be set to whatever you would prefer. Then we've got the title, the X label, the Y label. And so that's our histogram. And then we also want to set the curve over it. So to set the curve over it, we have to use this curve function. And then we're going to use denorm, which is the function to call standard deviation function. Yeah, there is an inbuilt standard deviation function. Yes, so breaks are the same as the bins, and there is an inbuilt standard deviation function. I'm not sure why it's not done that way, so you could do it that way if you'd like. But this denorm is calling a normal distribution to your data. So you set the X, and then we're setting its mean as our mean from our data set, and its standard deviation as the standard deviation from our data set. Then we're setting its color to red. You could set it to whatever color you'd like. LWD is the line width. So if you want it a bit thicker or thinner, you can toggle with that. And you have to click, you have to change add to true, because if once you set add to true, that means that it'll overlay it. So X in the denorm refers to the data being used for this curve. But since we're using the denorm function, it's just sort of like a dummy value. So you just leave it set as X. Because the denorm function itself is using a normal or Gaussian distribution to set the values for the data. So it's not actually using the data in the, yes, so it doesn't mean that this is a normally distributed data set. You can make your own interpretations looking at it. So it is sort of slightly skewed to the left. You could argue that it better suits a different distribution if you'd like. But I guess that's the point of sort of fitting over the normal curve, is to have a look at it with the curve over it, and then it's sort of easier to see. So M is referring to the mean up here, so you couldn't change it to M. It would confuse the R. So that's sort of how we fit it over for graphing for R. So if you are interested in using graphing for mathematical uses, you can sort of, might not be as useful, but for any students who are going into some more maths, especially data science maths units, this is sort of a useful solution. So as someone said before, yeah, this is a normal distribution. There are different ones. I'm pretty sure off the top of my head, P norm is, no, I think this is the Gaussian one. So yeah, it doesn't work because you have to set it a bit different, but there are ones for Poisson distributions and binomial distributions that you can set as well, if you'd like, if you look them up, so that you can overlay different distributions curves. But yeah, this is the normal one, and then you can use that as a visual tactic to sort of look and see if you agree with that. So that was base R, and now I'm going to hand over to Josh to lead us through the ggplot graphing. Thanks, Josh.
All right. Hello. Okay, so another library you can use in R is ggplot. And so ggplot is one of the most popular libraries in R, and it's often used for like scientific papers and production. and a lot of industry stuff uses ggplot. So it's really customizable and powerful. I think the downside is that it might take a little bit more text to produce some basic graphs, and it might take a little bit longer to learn. But really, it produces graphics that I think look better and are more customizable than the base package. So the fundamental idea of ggplot is that you create like an underlying plot, and then you specify what aesthetics you want. So these aesthetics will map columns onto variables, and then you specify what kind of geom you want. So that's short for geometric object, and that'll tell us what we want to draw. And then we can specify other modifications like legends, titles, and axes. So we'll see these different types of plots before, and in ggplot, there's called geoms. So it will specify them by calling something like a function like geom scatter that will add a scatter plot, a geom point, which will add like a scatter plot, all the points from scatter plot onto the thing, and geom line will add a line plot, like geom box will add a box plot. So we'll start out by making a scatter plot, and so we'll save some, we'll do some wrangling on this house data here, and we're going to add a new column called house age, which is 2021 minus the year built. So that's how old the house is. We'll run that, and so we also have some NAs like we saw before from the summary statistics in this data, and so we'll remove them, and we can use the drop NA function from dplyr, and that'll just drop all the NA values in house data. So we've saved this in house data 2, and that's all the rows that don't have a that have a year built. So we can see we've lost a few thousand observations here. And so then we'll investigate here, and we'll see, well, other houses that are older, are they more expensive, right? So the way we do this in ggplot is we call the ggplot function, and then here the first argument is the data that we want to run for. So we've got the ggplot, and then we have the data. And now we're specifying here the aesthetic mappings. So this will tell us on what axis we want what column. So on the x-axis, we want the house age column, and on the y-axis, we want the price we want the price column. And for whatever we draw, we want the type to specify the color. So before we saw it was quite laborious to add each different type. Here we can just quickly say, okay, the color will be the type. And then finally, once we've specified the mappings, we can add the geom point. So if we change this, we'll create an entirely different kind of graph. Oops, sorry. There we go. So you can see we've created this graph, and we can see the houses here. They're still here, but we have this outlier that we saw before, right? So plotting can be quite useful for spotting outliers. So we see the house age. Most of the houses are quite reasonably aged, but then this one here is really far. So let's remove that from the data set. And so we'll remove that by using the filter function that we learned yesterday, and we'll filter all houses that are less than 200 years. So we'll discard everything that's older than 200 years. And we'll graph that again. So here we are, and here we've added some labels, like the age and the price. We can see here that, yeah, most of our older houses, they look a little bit more expensive. And we can see that most of the townhouses are newer, and most of the units and houses are the older houses. So box plots can also be created in ggplot. So like Bridget mentioned, they're an easy way to explore some exploratory analysis. So here we have box plot function, the ggplot function again. And so creating the base graph is the same for like all the different types of graphs. So if you specify the ggplot function to make an object, you specify the data, the aesthetics. So here we have x will be a factor of our type. So we don't want to treat the type as a number or character. We want to treat it as distinct different classes. And then this will allow us to create a box plot for each different type of house. So we have the price here, and we have property type here. So we can see that houses are the most expensive. They're median here, and they've got a high tail. So there are a lot of expensive houses around. But for townhouses, they tend to be cheaper and a bit less of a spread. And here for units, seem to have some outliers here, but they tend to be cheaper, and they tend to be sort of, yeah, around, what's that, about $600,000. And so yeah, so that's how you create a box plot, and then we've added some new labels as well, so property type here. So here, I don't know why that's there. Might use it later, but I think that's sorry about that. So we'll create some line plots as well. So line plots are excellent for investigating time series data, so we can see things increasing and stuff. So we'll have to do a little bit of wrangling. So here we're just going to summarize each region and each month that it's sold in. And so this is using house data, and we're going to group by the month that it's sold in and the region that it's from. And then we're going to take the average price of all of the houses in that region in that month. And so we've done that, summarized. There's a warning here because it does it by groups. But this has now created a new data frame month summary. We can see that over here. And we can see that in this month in the Southern Metropolitan region, the average sale price was like 1,009,000. And here in Eastern, likewise for this month here. And so if we want to plot that, we can take this summary data and we can use it to make a line graph. So here we take this and we go month summary, take the aesthetics, the X is the month, the Y is the price, the group is the region name. So we want to draw a new line for each region. So that's why we're gonna do that. And the color will also be the region name. So we want a new color for each region line as well. Then we're going to say, okay, we're going to do a geom line, and we're going to add some extra labels. And so when we do that, we can see, all right, for each region, I'll make this a little bit bigger here. We'll see, okay, so in 2016, this was the average sale price. And so we can see that it's slightly increased over the year and a half we have this data set from 2016 to 2017. And we can also see that the Southern Metropolitan is by far the most expensive, and Western Victoria is the cheapest. And also that we have no records for this Western Victoria, Northern Victoria, and Eastern Victoria before about, it just looks like April in 2017. So we have some of our data hasn't actually been recorded. And so otherwise we can see like a slight general trend of increasing. And we can see that the Eastern and the Southern Metropolitan areas are the most expensive. So now another way, we can quickly produce multiple graphs. So if we wanted to split our data into different sections, we can use the facet wrap function. So here we're going to add a facet wrap. And the way that we do this is we use the tilde character and we use type. So now, like we did before, we're going to split it into like house, townhouse, and unit. So we want to see, well, is there a difference between like the house age and the price? So maybe older houses are more expensive, but older apartments are say cheaper. Could be an example of something we might be looking for. And here we also have some things that we're specifying in the geom point. So we can tell it like, so we can either do an aesthetic mapping, which means it'll look at our data to decide what the points look like, or we can do it directly in the geom point function. And that'll just mean that all the points have these properties in here. So if we run that, see, well, we've got created 3 separate graphs, one for the houses, one for the townhouses, one for the units. And we can see that, well, it looks like the older the house is, it gets a bit more expensive. The house is about sort of, yeah, there's quite a lot of houses were built here just after the war. And it seems like there might be some poor record keeping because they're rounded to the nearest 10 years each house. We can see that generally there's a slight increase in the amount. See that there are a lot of townhouses recently. And then we can also see again that the older units, the post-war units tend to be, there tend to be a lot of them there, and they tend to have the same price as the newer units. And so bar plots. So now here's an example of sort of the customization you can use. So like how you can make a ggplot like sort of really customizable, and you can choose a lot of different things. So here we're going to look at the most expensive 10 suburbs. So we have the data, we're going to group by the suburb, we're going to summarize the average prices, the mean of the prices, and the count is the number of houses. We're going to arrange it by the average price and filter the top 10 the top 10. So we're gonna take data with only 10 sales. So we're gonna exclude some outliers. Like if a suburb say only has one house that's really expensive, we don't want to say, well, that's the most expensive suburb. And then we're going to take the top 10 results. And we're going to create a bar plot here. And now there's a lot of sort of customizable things here. So we're going to change the theme. We're going to change the fill of the bar. We're going to change the stat identity. So we're going to not show the legend. We're going to change the Y scales. We're going to put dollars on the Y axis. So if we run all this and show that, you can see that we can sort of create quite a customizable, pretty looking graph, perhaps more easily than say if we were to do it manually in with the base graphics. There's quite a lot of function here, and you can see that if you start Googling stuff, you can do a lot of stuff with Ggplot. Cool. So I guess if we have time, we'll go through Plotly. Otherwise, we have a few sort of questions here. Yeah, we'll split up into breakout rooms and everyone can have a go at those. So unless Jeremy or Bridget, do you want to say something before we go into breakout rooms?
So if anyone has any questions about Ggplot, they maybe just put them in the chat now. That'd be really good. So we can just cover those before we go into the breakout session and try to go through some of these together ourselves. No questions?
You just want to go through Plotly?
So I think we might go into the breakout rooms, do some questions, and then we'll come back and do Plotly after we've sort of had some time to play around. I know it might be a bit more interesting if people can have some interactivity time, but make sure that you don't leave because we'll be doing Plotly after, which is an even more sort of advanced type of graphing that we'll run through. So if there's no real questions about Ggplot in the chat that people want to run through, then we might go to our breakout rooms now. So you should get your invitations in a second. Yeah, so if you could all start joining your groups. We can do our Q&A in comfort for a run, I guess. So yeah, Josh, do you want to just lead us through it?
Sorry, just yeah, unmuting. So this is Plotly, and so Plotly lets you, it's like it lets you create like HTML widgets, which are visualizations. So these can be like interactive, and so I showed some people before, but we can if we share the entire screen, we can see that we can like knit these files into HTML files to present our analysis. So this gives us like the ability to create sort of interactive and quite advanced visualizations. So it's a different library. And so there are quite a few visualization libraries. This is often used to create these kind of interactive ones. And so here's the syntax just for how to create a simple scatter plot thing. And here we have like the data is the house 2 data. The X is the number of bedrooms, Y is the price. It's going to be orange. It's going to be a scatter plot. I'm not sure what name does. I'm not that familiar with it. And so then our hover over will be our price. And so we're pasting the price. So this is, can't remember exactly this. I think this is like a JavaScript syntax, and that pastes that's the price of the Y coordinate, right? Or the $sign, and then it'll have the Y coordinate. And so then we have some customization here. So we have the layout, the x-axis, the title, and then we call it again to display the figure, and that will put out this interactive one. So the on hover template lets us have the hover 9 million for each data point. So we can investigate that, and we can like zoom in. So what does the tilde do in that? I'm actually not that familiar with.
I can.
Yeah, go. Yeah, if you.
So the tilde has to be there for Plotly. It's just the Plotly sort of syntax. So whichever column you want to call for your X or Y coordinates, you have to put it before it. It's sort of like, because we're calling the data at the front, where it's the data, it's just showing it that it's from that data source that was originally called. So just if you remove it, it'll throw an error because it won't know what bedroom 2 is, or it won't know what price is. The name here is just the name of this plot. So with Plotly, one of the advantages is that you can overlay plots onto each other, different types of plots. So you can overlay like this. Yeah, so it's telling that column is that tilde is sort of is, you can think of it as the data frame and that $sign, but it's not there. It's just telling it, that's what it means. So the name refers to the plot name. So we've just had it as blank because we don't need a name for this plot. But if you want to overlay multiple plots, you can give them names. So if you overlaid the year of the houses in a line graph, you could name it year, and then house price. But it's sort of more for your own benefit. But yeah, so we didn't go too much into Plotly because it's similar to Ggplot in the types of plots that you can make, but a little bit more interactive in the way that you can call each individual point. So if you scroll down, Josh, you can see, oh, it's been zoomed in. So because I think if you click the home, it'll send it back to its.
Double click.
Yeah, it resets the axis. So you can see that you can even in Plot, you can hover over every individual data point and you can see its value. So that's very useful if you want to make a very interactive sort of visualization. As you can see with Ggplot and the base, they sort of all start to, zoom together. You can do more advanced graphics in the ways of like text. So if you want to put text over each individual point or point out a specific one. So for example, maybe if your house was in this data set, you could put a text above the individual point saying my house. So we have put a link above to the Plotly package info, which goes into more depth from it, but we will probably cover it in a little bit more depth in our advanced R workshop. So if you have a play around, you're really interested into it, you can register for the advanced workshop, but that's not for a couple of weeks. But yeah, just thought we would let you know about it to tie in with the end of this workshop. But I think that concludes sort of the formal lesson part of this workshop. So we will stop recording now.